Hi everyone, really exciting to be here with you today. And Tanya and I are wearing the headphones along with you so we can hear each other. We wanted to start out and ask for those of you here, how many of you would be interested in a blockchain 101 to just kind of go over what is the technology, how does it work? And if you're interested, we can't hear you, so please raise your hand. Okay, we're seeing a few hands. I think we'll go ahead and Tanya's going to give us just a super short blockchain 101, and then we'll go into just asking each other some questions and sharing some more information.
Thanks very much. So I always say trying to describe what blockchain is about is a bit like trying to describe the internet in 1995. It's abstract, no one quite knows where it's going yet, and everybody's making a huge number of unsubstantiated predictions about what will happen in this space. But I'm going to try and just spend 2 minutes on this. So up until very recently, we've had no way to transfer value to one another without going through an intermediary over the internet, okay? So this was mainly because of the double spend problem, which means that anything that was kept in a digital format could be copied. So you could have a photo or a Word document or anything like that. So if you think about it, when it comes to money, you can't actually start having copies of the same thing because otherwise we end up with a huge amount of money all over and there's no track of it. So what happened is we had to use an intermediary to trace that money. So you would go through a bank, or in my industry where I come from, you go through something called the Central Securities Depository, which is keeping track of who owns what shares to facilitate who actually owns that, and that person would be keeping a ledger of who owns what. And then in 2009, Satoshi Nakamoto came along and published a white paper which came up with the concept of Bitcoin. And for the first time, we had a way to actually transfer value to each other without going through an intermediary. So I didn't need a bank to send money. I don't need a credit-worthy agency deciding whether I can buy a car or not. I don't have somebody else keeping verification of my identity. I don't have a music streaming company if I want to download songs off the internet deciding what music I should listen to or shouldn't listen to. Instead, I can get that directly from an artist. And I can now have anything of value between myself. And the way that this works is that as opposed to having the central authority, you have a network of computers that are running a very sophisticated algorithm that's keeping this data in sync as to who owns what. In the Bitcoin example, that network of computers is incentivized to run that algorithm and keep this database up to date. You paid in Bitcoin in that particular example, and it's really, it's about this community base. So out of everything I've said, if you want to take two things away, you can transfer something peer-to-peer without going through an intermediary, and the second thing is it's creating a community-based system with a network of computers that is running how this whole process works. And when we say that industries might take jobs away when we speak about things like that, imagine what this can do to whole industries that we currently use as these independent parties. So that's very simply what it is. I want to add one more thing in this space. It's also very important just to notice that in Nathana's talk today and then Alex's talk and the one we've just had now, there's some blockchain projects that are working in a permission space or what you would say a private space where there's just a collection of organizations working on a project. I would say that's very much like comparing it to an intranet site, and there are these open public blockchain projects which I would refer to as something very similar to the internet. So that's an important distinction to make, and when you're looking at a blockchain project, you need to understand which one of those projects you're working in.
So thank you, Tanya. I'm going to add one thing to that. So how many people here know how to send emails? How many people have sent an email today? Everybody, right? It's at lunch, so do raise the hand. Now, how many of you really understand the distributed network system, the underlying mathematics of the internet that actually governs how the ones and zeros that make up your email get from one place to another? All right, I see one hand. If we could talk, I would have you come up to this stage and explain it. But it's tricky to really understand the underlying mathematics, but you can understand from a conceptual level sending emails. And so with blockchain technology, what I invite you to do is to think about it from that more conceptual level. There's the mathematics part. For those of you that are hardcore engineers and mathematicians in the room, you can get into that, but you can still use the internet without necessarily understanding the underlying mathematics. So if you're thinking from a conceptual level, what is blockchain technology? You want to remember that information, instead of being kept by a central authority at the front of the room, now each of you can have a copy. and each of you can have a copy of the information. And maybe we can all understand, look, we have some transactions that have happened in the past. Think about a piece of land getting passed from person to person, and everyone might have a copy of the full set of transactions. But what happens when there's a new transaction? Who decides how that new transaction gets onto the network? And how does the same transaction get onto multiple copies at the same time? And that problem, how do you update copies at the same time in the same way, is a really difficult problem. And that's why that problem was only first solved in 2009. And so Bitcoin was the first practical blockchain because Satoshi Nakamoto solved that problem. How do you update the network in the same way at the same time? And as I went through in my talk, cryptographers are working now very fast on creating new technology and advanced methods for updating the network in the same way at the same time. What you need to care about is, do you have a reason to use a blockchain? Do you care about the audit history, right? Do you care that you write down information in a way that it can't be erased and it can't be rewritten? It can only be added upon. And do you want trust between parties that don't trust each other? Do you want cooperation between parties that don't trust each other? If you want those two things, well, then you might want to consider using a blockchain database. And so on a related note, I'll share with you an example of a project that I'm really excited about. So one of the challenges that prevent adoption of blockchain technology is that to use blockchain in its full-fledged way, where you get that updated network and you get the trust without any intermediary, you really do need to spin up a node of the network, and you almost always need an actual desktop computer. It's very difficult to use a full-fledged blockchain on mobile right now. What we have mobile clients. So you can use mobile. The mobile client, when you go into your mobile application, sends information to a company. That company puts the information to the blockchain. And so you still have some intermediaries almost all the time when you use blockchain on mobile. So one project that I'm very excited about is a project called MobileCoin. And MobileCoin is developing secure, fast mobile payments that can plug into a chat application, Signal, WhatsApp, a native chat application on mobile where you can actually run a blockchain node on the mobile phone. And whether it's MobileCoin or some other project, that's a really key place for the development of the technology. And so, Tanya, I have a question for you. So I mentioned Project Coca in the talk. It was very exciting to me to, I have been really fascinated having the opportunity to be here, learning about the ways that this technology is being used in Africa. And it's fascinating that the banks in Africa are actually moving forward with a successful blockchain pilot. And Tanya's been involved in that. So, Tanya, can you share more about what that means and where it's at and when the Rand is going to be blockchain based?
I never want to speak on behalf of the South African Reserve Bank, and I need to be careful that I don't. But in South Africa, we've got something called the South African Financial Blockchain Consortium. It's got almost 50 members at the moment, various financial institutions, consulting organizations, some vendors and things like that. And really, it was an initiative driven by the SARB to tokenize the Rand onto the blockchain. And what they did is they used it for wholesale payments. There were a number of banks involved. And what they could actually prove is using this technology to move the end of day or the interbank payments between themselves during the day. And as Nathana mentioned in her talk earlier, it was really around how fast they could do it, and could they have the privacy that is well, blockchain's supposed to enable transparency, but could we actually have privacy? So if I use some examples, they were able to move this cash in a wholesale system, and using a consensus algorithm as part of it, you could actually get one bank to verify another transaction between two banks without actually seeing the details of that transaction. And for me, when I sat and watched the demo that the SARB did, the fascinating part is right now, our central bank is actually running something called the RTGS system, or the SAMOS system, the real-time gross settlement system, or the South African multiple options payment system, nothing like a few acronyms. And they're running the payment system for the country. But if you look at this blockchain environment and we speak about how does it change things or how does it enable peer-to-peer environment, what happens is that through the POC that the SARB did, they actually just become the issuer of the currency, and they become the regulator, so to speak. But in what they did with Coca, they still ended up been a no to, for consensus. But really what it showed is that the role of a central bank could actually change from being an organization that might actually run and operate a payment system to one that's actually just potentially issuing the money and as I say, providing that regulatory oversight. And I think the important thing about Project Coke is it called into question what is the role of a central bank? How does this work? How would banking work? And I don't think that the Reserve Bank's about to throw away, the SAMOS system overnight, but I think it started to open up a number of doors and say, is there a better and different way for us actually to be moving money within our banking system on a wholesale basis? So it was very exciting.
I think related to what Tanya said, and the way that blockchain technology can transform industry, if you're in financial services right now, if you're a bank or you're an insurance company, or you're operating, you're in the role of a Visa, where you're securing identity between the acquiring bank and the merchant bank. If you're in financial services, you're making money as a middleman. You're making money as an intermediary. So if you have a central bank, the central bank says, we have X number of dollars or X number of rand, and then banks get to lend out that amount plus, right? They keep a small amount in reserve, they lend out the money, and they get to make money on the interest on the difference between what they lend out and what they keep. And now with this new technology, a central bank could do that themselves, right? Central banks don't need banks in their traditional way anymore. And that's very powerful.
Tanya, I wanted to jump in and say, I think there's always a lot of skepticism in this space, and I wanted to ask you, we've seen a lot of challenges around the technology scaling and electricity and all of that. What are your views on where that will go?
So in my talk, I talked about the future of blockchain, and the issue with scaling and the issue with electricity comes down to how do you update the network in the same way at the same time across nodes? So if you use the old way, it's the first way. If you use the old way, the way that Bitcoin uses, it's something called proof of work. And what proof of work is you basically have people using the network, and then on the side you have miners. Have people here heard about Bitcoin miners? So what the miners are doing is they're competing with each other, using lots of computing power to see who can solve a very difficult mathematical problem first. Now the problem is difficult because there's no way to solve it except for brute force. What's the problem? Every single block on the Bitcoin blockchain has a number. 1, 2, 3, 5,789, 689,973, and on, right? And before the number of the block, there's a random number of zeros. And the first miner to figure out how many zeros are in front of the block is the one that gets to say, hey, this is the new block that every single node will update the blockchain with. Now, if I want to cheat, I've got to spend computing power solving the problem and figuring out how to cheat. But because all the miners are all putting as much computing power as they can to solve the problem, no one has enough computing power to solve the problem and to cheat. Do you guys see that? And so basically what happens is, at first, when Bitcoin was first made, people were mining Bitcoin very fast with very little energy. But then Bitcoin started to become more valuable. So people started using bigger computers, because the bigger your computer, the more powerful your computing power, the faster you can solve that problem of the number of zeros. But the network is set up to only enable the problem to be solved every 10 minutes. And so what happened was, the Bitcoin network started adding more and more zeros ahead of that number on the block. The extra zeros you have makes that problem exponentially more difficult. And so it's this arms race of people putting more and more energy into play to just try to solve this problem. There are new ways of updating the network. And those new ways of updating the network don't require mining. So they basically have an alignment of incentives between the people using the network and the people validating the network. So there's something called proof of stake. There's a stellar consensus protocol. So there's a number of different consensus protocols. What matters for you is that if you care about having an audit trail that's as secure as what you can get in blockchain, and you care about trust across entities that don't necessarily trust each other, trust between countries, trust between companies, that's when you want to think about using blockchain, and then you work with your IT department and you work with people who understand blockchain space to figure out which consensus mechanism to use. So for example, the Stellar Consensus Protocol works very differently from the Bitcoin Consensus Protocol. It's much faster. And so what I'm seeing is private blockchains, like the Maersk blockchain, like some of the ones that I talked about in my talk, they're not using proof of work. And even Ethereum, has everyone heard of Ethereum? So you have Bitcoin, that was the first real blockchain that worked in the wild. And then Ethereum is not the second, but it was a second major advance over Bitcoin. Because with Ethereum, you could actually start to make these programs on top of the blockchain. Ethereum also uses proof of work, but the founder of Ethereum has said that they are basically trying to move Ethereum to proof of stake. And so what Ethereum's been doing is it's been reducing the reward for miners who put computing power onto the Ethereum network. And as I mentioned as well, Tezos is a live network right now that's using proof of stake. So we find this technology evolving so rapidly, and I think that's how we're going to solve the scaling problem and the energy problem. Because you know, the internet, when it first started, when people were using email in the 70s, it was impossible to use email. You had to be a really good programmer, and people were only using it in the lab, and they thought it would never catch on. Now we've had advances in the technology that make email clients really easy to use. So we can all use it whether or not we understand DNS. So Tanya, I think this may be our last or second to last question.
We've got 3 minutes left.
But since you're involved with industries actually running blockchain pilots, and I'm guessing some people in the audience might be interested in trying this stuff out, what would your suggestions be for actually doing a pilot?
Yeah, so I think there's 2 very important things. You know, we seem to, I'll go back to that concept of working on a permissioned blockchain project and a public one. You need to have a clear understanding of which one you're actually working on. If you're working in this permissioned, or what I described as the intranet space, you're probably working in a closed group with a consortium of you know, your dearest competitors, and that sort of environment is a very different one. If you're going to be working in a project that is public and anybody can sign up to, and I'll refer back to the session before that starts speaking about this peer-to-peer environment, or this community-based type of economy or system that you're trying to build, that's a very different project that you've got to work on. So just my first recommendation is just be clear on where you're sitting in terms of those 2 camps. And then you obviously need to educate yourselves, and one of the key things around this is it's not about, you know, understanding the technology, you know, as Nathana's touched on now. This is about understanding, you know, everything from economics to game theory to cryptography to, you know, how society works, how they incentivize. There's far more important things, and what I encourage people to do is actually get a more diverse group of people involved in these sort of projects to actually understand it beyond just your IT problem. And then I know everybody says, please make sure that there's a real business problem that you're trying to solve. I've taken that as a given. Don't just throw blockchain at it and try and solve that. I've taken it that everybody here is highly intelligent and won't do that. So that's my advice offhand, and yeah.
Cool. So I think with our last minute, one of the things that I want to stress is, I think this is a challenging topic because it's abstract. And on the one hand, it seems like there's incredible use cases. It seems like there's hype. And then it can be really challenging to wrap your head around it. And so what I invite you all to do is, when you think about it, try to take the term Bitcoin and the term cryptocurrency totally out of your vocabulary and try to do some research thinking about it from the technology itself. And a really good book, if you want to learn more, is called Truth Machine by Paul Vigna and Michael Casey. And that book actually came out just this past March. And these 2 authors wrote another book in 2016 called The Age of Cryptocurrency. And in the book that came out in March of 2018, they say, hey, that book in 2016, don't read it, because the information is all old and outdated. And so this is a space that's evolving very rapidly, but Truth Machine is a book that I feel comfortable recommending as a place to learn more about blockchain technology. And then once you've got that under your belt, you'll be able to learn even more. But I think take hope being here in Africa, because there's real use cases that people are feeling very keenly. And so it means that people are experimenting, and Bitland is happening here, and Dala is happening here. And I think we're going to continue to see a tremendous amount of innovation happening here in a way that will drive adoption here even faster than in the developed world. Well, thank you all for taking your time to listen to us.